Hello and welcome to Avantika's Notes. In today's note, we're going to talk about different techniques that are used in system where client needs real-time updates from the server, aka real-time communication. In apps like messaging, stock price tracking, etc., techniques like long polling, server sentiments, and WebSockets are used. These are also some terms that appear in system design interviews. So in today's note, we're going to understand what each one of them mean, why they exist, and when to use which. Let's start with the simplest and most baseline approach, polling. Polling is a technique in which client sends multiple requests to the server at a fixed interval to ask if there has been a change in the data. This is a very simple technique that's built over HTTP GET request and is very easy to implement. It is a practical approach for scenarios where we want to show the progress of a background long-running task to the user. Let's imagine a scenario that a file upload task is in progress. The client wants to show a progress tracker to the user. The client will send a GET request to the server, and in response, the server will send the status of the upload saying in progress along with the percentage that has been completed. After the 2 seconds of fixed polling interval, the client will again send the same request, and in response, the server will send the updated percentage of file upload. This will keep on happening every 2 seconds till the file upload is completed. Because of its simplicity and ease of implementation, it becomes the right choice when we want to get updates which happen over a span of a couple of seconds and the data does not change every millisecond. Now, polling has a few disadvantages as well. So it is important to understand when not to use polling. So polling introduces a fixed latency based on the polling interval. Let's understand what this means. So let's say client makes a get call to the server and no new data is available. So server is going to send an empty response. Right after the server sends an empty response, new data becomes available. But the client will wait for 2 seconds, which is its polling interval, to make a get call again to the server to get the new data. So this latency can be seen as part of polling technique. Another disadvantage of polling is waste of server resources when the updates on the data do not happen as often and most of the polling requests to the server are returned with empty response. What if we want to reduce the load on the server by trying to reduce the empty responses as much as possible and get real-time updates as soon as they happen? Long polling tries to solve exactly that. Long polling is an improvement over basic polling. So when client sends the GET request to the server, instead of immediately sending an empty response, it keeps the connection open. When the new data becomes available, it sends the response with the new data. Server typically keeps the connection open for a couple of seconds, maybe 10 to 30 seconds based on the infrastructure. And if the new data becomes available during that time, it sends the response to the client using that. Otherwise, it sends an empty data or a timeout to the client. In this technique, client fires a new get call as soon as it gets the response from the server from the previous get call. So unlike polling, there is no latency in getting the updates and the updates are near real time. This technique significantly also reduces the load on the server because chances of getting an empty response reduce significantly. So long polling is the right choice when we are designing systems that want near real-time updates, but the updates are unpredictable. So we don't know when the updates will happen, but we want them as soon as they happen. But let's understand when not to use long polling by looking at its disadvantages. The first disadvantage of long polling is excessive server resource consumption. Every open request in the server consumes resources till it's completed or timed out. As the number of clients increase, this technique can become real resource intensive real fast. Long polling is not a good fit when it comes to high frequency updates. So imagine a scenario where new data becomes available in the server every few milliseconds. So every time client requests update, the server immediately sends the new data and closes the connection. Then client immediately sends a new request, a new connection is opened, and then new data is sent back to the client. Again, the connection is closed. Connection is constantly opened and closed. This causes a lot of connection churn and a load on the server. As the number of clients increase, this can become really unmanageable and bring down your server. So long polling is definitely an advantage over simple polling, as it is helping us reduce unnecessary requests to the server and is also helping us get near real-time updates. But it has a big disadvantage of connection churn. What if we could have a single long lived HTTP connection over which the server could keep sending the updates whenever they were available? Well, that's what is called server sent events. So SSE is a technique in which the client opens a connection with the server just once, and the server continuously pushes data on the same HTTP connection as soon as the new data becomes available. In this technique, the client does not have to repeatedly ask for updates, reducing the connection churn. So, this is a good design choice when it comes to designing systems where the updates happen frequently. So, for example, social media app, once the user opens the app, the client can establish a connection with the server. And when the user is scrolling through the feed, a new post becomes available, server can simply push that new post or new story onto the user's feed using SSE. In the client, we can easily implement SSE in JavaScript using event source objects. And there's a standard support in browser to re-establish the connection if it gets broken. There are a few limitations when it comes to using SSE though. Sometimes old browsers don't have support for SSEs, and even load balancers and proxies at times don't support streaming. There are two scenarios in which SSEs cannot or should not be used. The first scenario is when we want two-way communication between the client and the server. So this single HTTP connection that has been established between the client and server as part of SSE can only be used by the server to send data and cannot be used by the client to send data. SSE is not the ideal choice when it comes to designing systems with very high frequency of updates. We're talking about hundreds of updates per second. This is because SSE streams from server are typically text-based, and hundreds of text-based events per second can become really inefficient as they create lots of small packets to be processed by the browser. A better alternative in such scenarios is a WebSocket protocol where the events are in form of binary packets which can be easily batched and compressed to improve the efficiency. So WebSockets provide persistent connection just like an SSE, but they are bidirectional in nature while SSE was unidirectional. This means that on a same connection, client and server both can send messages. The way WebSockets work on a high level is that the client first starts with an HTTP handshake and then upgrades it to a WebSocket protocol. Once the connection is established successfully between the client and the server, the messages can flow freely in terms of text or binary frames until the connection is closed by either the client or the server or a network failure happens. Now, do you know when to use WebSockets? Well, of course, when we want two-way communication between the client and the server, very low latency real-time updates, or when we want to track very high frequency updates because it is very efficient. Now we know when to use WebSocket connections during system design, but it is also important to be aware that WebSocket connections are fairly complex to implement as compared to the other HTTP solutions we discussed earlier. This is because they are persistent and stateful in nature. So we need a special logic in the load balancer to handle these connections. As well as we also need to be aware that during deployment, if we lose these connections, we need a way or a logic to re-establish them. It also needs special handling when we are scaling up or scaling down our servers. Moreover, as the number of clients increase, the resource consumption on the server also increases because of these persistent connections. I hope you found this note useful and it helped you understand the main techniques that are used in real-time communication. So next time you face a system design interview, you will be able to choose the right approach and ace that interview. See you in the next note. Bye.